types of data. You know what? When I was working on this slide, it's only when my slides are done, when I came to realize that you are in fact from IT and computer science, and I know that you are familiar with the types of data. In fact, that is probably the first topic that you studied when you took your first major course in computer science or information technology. So you know this, you're familiar with this. So we have a numerical data. So it's a data that conveys size, quantity, weight, height. And because they are they are data where we can apply mathematical operations on them. Okay, we can add them, we can subtract them, we can divide them, and the output is something that has a meaning. There are data that appear only as numbers in appearance. They are numerical only in appearance, but they are not really numerical data in the true sense of the word. So under numerical data, we have discrete numerical data and we have continuous numerical data. You know, when I think about discrete numerical data, I think about the set of integers. Okay? And the set of integers, you can count them. Okay? Although, of course, the set of integers itself runs to infinity. Okay, but they are still countable. You know what the thing about being countable? You can count them, the set of integers, but it does not mean that when you count them, you will end because the set of integers is infinite. You know what? In the real world, okay, again, you can make a comment. Okay, maybe you can make a comment if I'm wrong. In the real world, there is no such thing as infinity. The real world, the physical world, is always finite. It's like you can measure it, okay? So when I think about discrete numerical data, I think about the set of integers. And the set of integers are quantities or numbers that you can plot in your number line. And these quantities have gaps, okay? So that is what I visualize in my mind when I think about discrete numerical data. So they can be counted. Continuous numerical data, again, when I think about them, I always go back to my discipline, which is mathematics, pure math. And I compare continuous numerical data with the real number line, okay? So the real number line, you cannot count the set of numbers in the real number line, even when you just pick an interval, okay? And the reason why you cannot count them is because if you were to pick one number here and another number there, it's a real number. There are infinitely many numbers between them. It's impossible to count the numbers in an interval of real numbers. So what are the examples of discrete numerical data? Your outcome, the outcome of the grades in stat. Okay, so we only have, I think, 5 or 4 outcomes. Your grades can be 1, 1.25, 1.5, 1.75, okay? So the outcomes are countable. The size of family, how many are you in a family? And by the way, okay, I spoke about the census. So in the census, people from the Philippine Statistical Office or Philippine Statistics Authority, they go places. And the purpose of the census is really to visit all households. That's the purpose of the census. And when they reach a household, they will ask people there, how many people live in this house? So the size of a family will be an example of a discrete numerical data. How many TVs do you have? How many cell phones do you have? So those things, you know what? These people will ask you about those information. So that will be an example of a numerical data. The quantity of books in the library, the number of successes in sales, or maybe not in sales. Maybe you have not done anything about selling. Number of successes in courtship, for example, okay? So you're the kind of guy who must have tried courting a girl. And what is the number of successes? Well, 0. 0, because women always turn you down. And the number of failures. Okay, so that is probably more proper for you because all you can count are the number of failures a girl turned you down. Okay, how about for the chicks, for the girls? The number of successes in their participation in a beauty pageant. You know what? I am already 48 years old. No, 38 years old. Almost 40. When I discovered that beauty pageants are like sports in our country. Yeah, I was already a matured man, 40 years old, almost 40, when I discovered that beauty pageants are like sports. And so there, in a pageant contest, there is a discrete numerical data there. How many times had you been successful in a beauty contest? So those are examples of discrete numerical data. How about examples of continuous numerical data? Height of a person, the quantity of water in a bottle, and you know what? Your money, okay? Money in the savings deposit. Because let's say for example, you are just depositing 1 peso, 1 peso, 1 peso, but it earns interest, and the interest they are decimal numbers, and you multiply it to your money, which appear to you like a discrete numerical data. But after the passing of some years, it becomes a continuous numerical data because your savings deposit would have earned interests, and interest usually has a decimal part. Now, what are categorical or qualitative data? So these are data that conveys classification, typology, okay? You must be careful, of course, that there are numbers or there are data out there that appear numerical, but they are not numerical data. They are, in fact, categorical data. Okay? So these are data where applying mathematical operations of them carry no meaning. So these are data that conveys categories or classification. Now, okay, you must pay attention to this. There are categorical data that you can convert to a type of data that is somewhat numerical, okay? We will go to that when I go to the next type of data. But for now, what are the examples of categorical or qualitative data? Okay, so this, you are familiar with this, okay? Because you are working on forms, okay? You want to produce a form that will collect this information. Are you male or are you female? The names, so that is an example of a categorical data. Your year level, or your first year, second year, your course, the classification of living things, classification of plants, classification of animals. Those are categories. Classification. The plate numbers of cars, okay? And you know what? The plate numbers of cars shouldn't be called plate number. It should be called plate letters and numbers because it has letters. Okay, so this is the type of data I was talking about. You can have something like a categorical data, but you can transform it to a data that has some numerical character. And that being so, you can in fact apply a few mathematical operations such as ranking. Okay, so an ordinal data is a mix of numerical and categorical character. You can transform it into a numerical data and then you can rank it. Let's say, for example, height, okay? Tall, short, and then halfway between, average, okay? Well, that is how we classify people at a glance. Hey, you're tall. Hey, you're short. And then when they are average in height, we don't say they are average, but in our mind, hey, your height is about average. So those are classifications. Those are categorical data. But you can rank them. Okay, you can rank someone who is a set of people. Okay, they have categories, but you can rank them. Okay, from tallest to lowest. And sometimes you see this many times in survey. When you are evaluating, let's say for example, the service, excellent, satisfactory. Okay. Very poor, so on and so forth. So those are classification. Those are qualitative data or qualitative information. You are describing the quality of something. It's quality. But you can you can transform them into a data that has a numerical character in them, so that after being transformed into a numerical character, you can now rank it. Okay, you can now rank it. So ordinal data. Okay, so the keyword there is order. Ordinal, order. You can rank this data. Let us go back to this table and let us identify the type of data. Let's begin with characters that appear as numbers, okay? So this one, okay, I will use a different ink. Let's use, what will I use? Okay, let's use that. Okay, so that one obviously is not a numerical data. That is just a label. So that is a categorical data. Okay, year. Okay, what is that? Is that a name? Is that a true numerical data? Well, it's a categorical data. Okay, it's a qualitative data, because you can put together 2 years, 1997 and year 1998. What does it mean when you get their sum? It has no meaning. It's pointless. And so this one is an example of a categorical data. What else? Okay, now this one. Okay, so that one is a numerical data and a continuous type of data. Okay, the mean, the average. Okay, you're familiar with the mean. Okay, because you always compute your average score in your major exams. So you apply mathematical operations, you add, and then you divide. The standard deviation, another numerical data, and it is a continuous type of data. The range, okay? And by the way, what is this about? What is this about? This experiment is about the quantity in percent of unfertilized eggs of some insect. Okay, so this is what this experiment was done for. This one is numerical data, but it is a discrete data. It's the number of insects.